Hi everyone. Today I'm going to explain about organizing quantitative data, which means numerical data. So, uh, these numerical data we can divide into three groups, major groups we called single valued grouping, limit grouping, and cut point grouping. Why we need this grouping? Because we are dealing with numerical data. First, single value grouping. What is this single value grouping? If we are dealing with discrete data, we have to stick with this single value grouping. Use with discrete data in which there are only small number of distinct values. If you have few distinct values, which mean distinct numerical values, you can use this single value grouping. Limit grouping, used when the data are expressed as whole numbers and there are too many distinct values to employ single value grouping. If you have a discrete value and if you have too many discrete values, you have to use this limit grouping. Discrete distinct values. Okay, so single value grouping you are using if you have discrete distinct values, discrete distinct few values. Okay, you have to use limit grouping if you have discrete distinct too many values that you cannot deal with single value grouping. Last one is cut point grouping. Cut point grouping you can use when the data are continuous and are expressed with decimals. So if you have continuous numerical data, you can stick with this cut point grouping. Group into classes. First group the observations into the classes and then treat the classes as the distinct value of qualitative data. Okay, so that's how we group into classes. Important guidelines, I have mentioned few guidelines here. Number of classes should be small. Okay, try to keep a small number of classes as much as you can. Most of the time we say okay, a number of classes should be fair if you have keep them in between 5 and 20. Okay, 20 mean it's huge. Try to keep them very simple. Okay, each observation must belong to one and only one class. That's really important. If you consider a one observation, that observation cannot belong to two classes. Definitely is it has a one class. That's it. Whenever feasible, all classes have the same width. If you have few classes, try to keep the width of that classes same or equal. Okay, width mean size. Okay, size of that classes should be equal. Okay, almost all you have to keep that same width. Okay, okay, you will see what are these important guidelines later, how we deal with that. First group, single value grouping. How, at what time do we need to use this single value grouping? If we have few discrete distinct values. Okay, so in this case I think this according to this exam exercises, a survey considered to identify how many children do they have in a family. How many children? Definitely discrete and distinct. Okay, so there are few, they have considered only 12 people. So this is the data set, 0 1 3 0 2 2 1 1 0 1 4 2. So in this data set you should be able to identify what are the distinct values. So distinct value 1 0 I have mentioned here, 1 0 sorry 0 1 2 3 4. There are no children, 1 children, 2 children, 3 children and 4 children. So you can uh, mention them in a table like this, a frequency table. Number of children 0 1 2 3 4, these are the distinct values. So frequency, how many zeros here? I think there are 3 zeros, something like that. How many ones here? 1 2 3 4, there are 4 ones, something like that. You can mention frequencies. So when you come to the relative frequency, what is the total value here? I think 12, it should be 12. They have mentioned 12 people. So total frequency or total number of people is 12. So you for the relative frequencies you have to divide each frequency by 12. Okay, so for this one I'll write down it. This frequency, how many zeros? 3 zeros, sorry, 3 ones. How many ones? 1 2 3 4, 4 ones. How many twos here? 1 2 3. How many fours? There are only uh 1 4, sorry I forgot this 3. How many threes? Only one, right? So you can add this and check whether this equals to 12. 7 10 11 12, yes, it's equal to 12. So relative frequency you can find 3 over 12. This frequency divided by total number of people, 12. So this 4 divided by 12, this is 3 divided by 12, this is 1 divided by 12, this is also 1 divided by 12. Okay, okay. Next one, second group, limit grouping. Limit grouping we used if we cannot use single value grouping. Okay, in this limit grouping you have many distinct values. Okay, many discrete distinct values. So for that case, to avoid some confusions, we use some class limits. Some class limits. Lower class limit, upper class limit. So lower class limit means the smallest value that could go in a class. The lowest value of the particular class we call lower class limit. Upper class limit means the largest value that could go into a class. Largest value of that particular class we call upper class limit. Class width. Uh, Class width means size of the class, the gap of the lower limit and upper limit. The difference between the lower limit and the lower limit of the class and the uh, upper limit of the class, this should be upper limit. Okay, in here see the difference between the lower limit of a class and the lower limit of the next higher class. This can be upper limit of the same class or lower limit of the next higher class. Okay, that's correct. Last one is class mark. Class mark means the average of the two class limits of a class. Average of a two class limits. What are the class limits? Lower and upper class limits. So average of the two class limits is the class mark. Okay, we have 40 short-term investments. These values, there are 40 values. We are going to deal with our limited grouping. Okay, you have to identify what is the lowest value and the highest value in this data set. Then you can divide these uh, days to maturity into equal classes. See, Lowest value is 30, highest value is 99 in that data set. So from 30 to 100 or 99, you can divide this by 10. Each class size 10, something like that. 30 to 39, 40 to 49, 50 to 59, up to 90 to 99. Always try to keep the equal gap within these classes. This is what is the gap? It is 30 to 39. There are 10 values, okay, including these boundaries. Don't forget about that, including this lower value and upper value. 30 is included in this class, 39 is included into this class, okay. There are no values in between 39 and 40 because these are integer values, discrete values, okay. Okay, then you have to count the frequency, or how many times, how many values inside this class. So there are 3 values within 30 and 39 class. For there are one only 40 to 49. We will see this one 40 to 49. Let me check how many values. 40 to 49, 40 to 49, 40 to 49. I can see 47, and there are no any other values. So yes, 40 to 49, there are only one value. So likewise, you can get the frequencies, and at the end check the summation of this frequency should equal to 40, because we had previously we had 40 short-term investments. Then relative frequency, frequency divided by total number of maturity investment. 3 divided by 40, 0.075. 1 divided by 40, 0.025, something like that. When you add these relative frequencies, it should equal to 1. Okay. The last group is cut point grouping. We use this cut point grouping for continuous data. Same as the previous case, same as this limit grouping. This cut point grouping has lower class limit, upper class limit, class width, and here we call it midpoint because we cannot get perfect values for class average here. So lower class cut point. Lower class cut point is the smallest value that could go in a class. Upper class cut point means the largest value that could go in the next higher class, or we can say lower cut point of the next higher class. Lower cut point of the next higher class. Class width, difference between the cut point of a class, difference between this lower class cut point and upper class cut point. That's the class width. Class size. Class midpoint, the average of two cut points of a class. Two cut points, average of the two cut points. Two cut points you can find lower class cut point and upper class cut point. Okay, here the major difference between uh, previous case and this cut point case we use for continuous data. So as you can see here, 15 college students, we are dealing with weights in pounds, so that value can be 155.2, 167.3, so continuous values. Use the class width. How, what is the class width we need to use? Class width. So what is the minimum value? You have to go through these values and figure it out, what is the minimum value of this data set and what is the largest value of this data set. I think minimum value is 140 because I cannot see any value less than 140. 45 is there. I think yeah, 45. 145 is the minimum value, and the largest value I think 191. Yeah, largest value is 191.1, lowest value is 145.6. So you know, now you know what's the range. Okay, 145.6 to 191.1. Now you have to decide, okay, what is the size of the class. So I decide the easiest one, class width of 10, and we are going to start that value from 140. Okay, so class width is 10, 140, start from the 140. So 140, how we deal with this? 140 to width is 10, 150, 150 to 160, something like that. So first cut point is 140, class width is 10, so the first class is 140 to 150. So class width is 10. 140 definitely belongs to the first class, but 150 belongs to the next class. So the highest value of that uh, of that particular class belongs to next class. That's the difference. You will see this in next few slides. Okay, let's consider the class 160 to 170. What's the class width? Class width is easy, it is 10. Okay, let me write it. It is 10. Class midpoint 160 to 170. So what is the class midpoint? Average of these two, 165, right? 160 plus 170 divided by 2. That's how we find the average. Okay, round of error, there are error called round of error for the relative frequencies, because we have continuous data. So when you get the summation of relative frequencies same as before, you will see that value may or may not be equal to 1. It can be 0.9995, 998, something like that. Okay, but don't worry about that. Okay, uh, now I'm going to explain you how we draw this grouping, how we draw our data set, or how we represent our data set using those grouping. For that, those grouping cases are numerical cases. There are no visual stuff to see that, but we can draw them by using this technique. Okay, histogram. Histogram is a very important case, or very important diagram, or very important graph in statistics. Okay, histogram is displays the classes of the quantitative data on the horizontal axis and the frequencies on vertical axis. There are bars, but thing is that bars never touch each other. Okay, sorry, the bars, they touch each other. That's the important case. In bar chart, if you remember, in bar charts, that bars, they never touch each other. Okay, but in histogram, it's a must to touch them each other, so there is no gap between bars. So we can use this histogram for single value grouping, limit grouping, or cut point grouping without any problem. So let's see what we have to do. First step is obtain frequency distribution of the data. The next step is draw a horizontal axis on which the place the bars, and vertical axis on which to display the frequencies. or relative frequencies. That's fine. For each class, construct a vertical bar whose height equal to its frequency. So height equals to frequency. Same idea behind the bar chart. The last step is label the bars. Label the bars. Okay. Uh, let's consider this frequency and relative frequency distribution. Okay. Number of TVs. Number of TVs, they are discrete, distinct values 0, 1 to 6. So frequency they have mentioned here, there are 0 number of TVs 1 number of TVs 16, something like this. So total number of TVs 50. Okay. So when you find the relative frequency, you have to divide each frequency by its total value. 1 over 50, 16 over 50, 14 over 50. Here 2 over 50. So when you add them together, when you add these relative frequencies together, it is equal to 1. Okay. Now you can use frequency or relative frequency. This is a perfect drawing of a histogram. See this mentioned in the left hand side histogram. Y-axis or vertical axis belongs to frequencies. X-axis number of TVs. So 0, there are 1, right? There are 1 TV. There are 1 zero number of TVs. There are I think 16 one number of TVs. Okay, something like that. Uh, so likewise you can read this. See, there are no gaps between these bars. Okay, same as you can draw the relative frequency instead of this frequency. At that time, this huge range shrink to 0 to 1 range relative frequencies, because relative frequencies, see, all are small values less than 1. So when you get the relative frequencies according to these relative frequencies, you can draw the histogram like this. Check the shapes of this graph. See, this shape and this shape, they does not, what they do not change. It doesn't matter if you use frequency or relative frequency, shape doesn't matter. Okay, shape doesn't change, so it doesn't matter. Okay, uh now let's see another one. According to this example, now we are going to use limit grouping. We use limit grouping because we cannot use single value grouping. So in here, 30 to 39 class width or 30 to 39 class, we have three frequencies: 3, 40 to 49, 1, 50 to 59, 8, so on. Total is 40, so you can find the relative frequency 3 over 40, 0.075. Here 1 over 40, 0.025, something like that. Now you can draw the frequency. Okay, I'll show this. 30 to 39 frequency is 3. Okay, we'll see 30 to 39 frequency is 3. See, here it is 40. Now you don't confuse with, here it is 40. 40 belongs to next class. Okay, 40 belongs to this class, not this one, this one. Okay, let me draw that one. Let me show that one. 40 belongs to this class. Okay, always the highest number 50 belongs to this class. Clear? So height represent the frequency. Same as you, if you want to use relative frequency, you can go like this. Only difference is this relative frequency or frequency values. That's it. Shape, it doesn't change. Okay, here the thing is, you have to use this uh, interval 30 to 40, 40 to 50, 50 to 60. See, 30 to 39, 40 to 49, 50 to 59. In here you cannot see 39, 49, 59. You can see 30, 40, 50, 40, 50, something like that. Okay, but remember that in limit grouping, the highest number or the upper limit belongs to the other group. Okay. Okay, third one, cut point grouping. So if you use a weight of the 18 years old to 24 years old males, okay, here we have only the graph or histogram. uh, I don't know why we don't have this one. Okay, just for an example, you can see 120 to 140 there are 2.5. Okay, there are 2.5 males. It's a male of frequency weight in between these two. So 120 and 140 within this group. Okay, 140 to 160 within this group. Since these are continuous values, it doesn't matter. There is no problem with these limit values. Okay, so don't worry about that values. Same as the previous case, limit grouping. Only difference is these values are uh, continuous values. Okay, so when you do your homeworks, you will identify or you will understand actually what is going on here. Okay, dot plot. There is another plot we call dot plot. It is a graph in which each observation is plotted as a dot at an appropriate place above a horizontal axis. Equal values, if you have equal values, then stacked vertically. It's like this. To construct dot plots, draw horizontal axis that displays the possible values of the quantitative data. So draw a horizontal axis, then mention all the possible values here there. Then record each observation by placing dot over appropriate value on horizontal axis. Finally, label the horizontal axis. Okay, here I have mentioned my data set. This is my horizontal axis, and I have mentioned each possible values. 190, 200, 210, 220, 230. Between these values, I also mentioned these values. I can represent 191 here. This 192, 93, 94, 195, something like that. Okay, so I can represent all values from 190 to 130. Okay, 210. 210 goes to here 200. Okay, here 210. So this dot belongs to 110. Next, let's go column wise. 224. 220 is here, 224 is here. See, dot. 208. 200 is here, 210 here. This is 208. Okay, this is 208. 212 again, 10, 12. 212 is here. You can see here 219. Okay, 219 is here. Another 219 here. See, another one. So it goes up here. If you have another 219, it goes here. Something like this. You can stack them on top of the previous one. If you count how many dots are here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. There are 16. Yes. Okay. This is how we represent this dot plots. There is another diagram. It's a very basic diagram we call stem and leaf plot, this one we call normally, in general we call stem plot. In a stem and leaf diagram, each observation is separate into two parts. Each observation is separated into two parts. We call that stem and leaf. Stem always goes to left side, and leaf goes to right side. So always has only one digit. Remember that leaves always have one digit. All other digits goes to stem. Okay, left side. Think for each observation as stem consists of all but the rightmost digit and a leaf the rightmost digit. Step number 2, write the stem from smallest to large. This is really important. Always you have to write the stem from smallest to large, increasing pattern. Okay, write each leaf write each leaf to the right of the vertical rule in the row that contains the appropriate stem. At the end, arrange the leaves in each row in ascending order. That's the final step. Okay, I have 40 short-term investment here. This is my data set. This is stem, this is leaves. So first you have to draw a sketch. Okay, uh, start from the smallest value. So you have to go through this data set and find the smallest value and maximum values. So my smallest value is 30 something. Okay, 38 or 36 I guess. So 30 to 90. Okay, so leftmost digit comes to stem part. So 3 4 5 6 7 8 9. 3 mean 30 values goes to this row. 4 mean 40 values goes to this row. Likewise, 9 mean 90 values goes to this row. Next, you can find these values. You can see, let's go row wise. 30, okay, 36. I missed one. 38, yes, first 38. So 3 is 30 here, so you don't need to mention 30 again. 8, which means 38. So 8, only rightmost digits. Okay, only right digits. Then 36, then 39, 9 here. So 8 6 9 in left side. Likewise, you can continue this. Then you can get something like this: stems 3 4 5 6 7 8 up to 9. Leaves at the end you have to put them ascending order: 6 8 9. Here 7. See, 0 1 1. If you have two values, doesn't matter, keep them in ascending order: 0 1 1 3 5 6 7. Ascending order is a must, so you have to keep them in ascending order. In this one you can see we have 3 digits. Doesn't matter, leaf always belongs to 1 digits, always 1 digits. See, so all digits except rightmost digit you have to push to the left side, which means stem. So in this case I have 2 digits in my stem column. Okay, this 19 mean 190 values. 20 mean 200 values. Okay, 20 mean values belongs to 200, 201, 203, 200, 205, something like that. Okay, so you can use this. Again you have to keep the ascending order in leaf side. So always leaves are in ascending order. See, it doesn't matter how many zeros you have, ascending order. You can if you feel okay there are too many values in this row, see 21 column, there are too many values, which means 200, 210, 210, 210, 210, 202, so on. So you, if you want, you can split this stem into two pieces, like uh, 100 values below 195 here, values above 195 this part, values below 205 here, values above 205 here, something like that. You can split this one stem row into two pieces. Okay. Okay, that's the last part of this section about how we define or how we draw quantitative data. So I believe that now you have an idea about how we deal with this quantitative data. So I hope to continue this section in next video about shapes, to identify shapes. So hope you guys will enjoy the video. Thank you for watching this and see you soon.